In a previous video, we talked about why this proposition and proof are correct. And then in subsequent videos, we talked about why this proposition but proof, why this proposition is true, but the proof is incorrect. And the same went for this one here. Same went for this one here. And now we get to yet another example with the same proposition, the same correct or true proposition, but incorrect proof. All right, and you can see here that a lot has been left out from the original correct proof in 4, what's labeled problem 4. This being labeled problem 8. Okay, and so here the issue is that there's a sentence in the proof that does not directly follow from the sentence that came before it. Okay, so we have B and that. All right, so let me try and explain that to you now. All right, so the first two sentences follow correctly. You state the assumptions in the first sentence. The second sentence follows directly from the first sentence. But then you see from the second to the third, there's no real indication of why x plus y is equal to 2 times n plus m plus 1. Now, this whole idea of one sentence following directly from the one that came before, or is also somewhat of a vague notion. And I'll admit that. What seems to follow for one person may not follow for the other. And certainly, to highly trained mathematicians, what follows from one sentence to the next might seem like it does not follow for a beginning mathematician. As an example, for a well-trained mathematician, the proof of this proposition would be something like, well, it's obvious. End proof. Now, of course, to you, you would say, well, can I just write, is it obvious in every, okay, and I'm not having you actually write the proofs. In this Math 189 class. But in previous classes, when I would have Math 189 students write proofs, they would say stuff like that. Well, it's obvious. But, and so what I would say to them is like, okay, well, you have what follows from the line that came before. How do we sort through this vagueness? And that is that, so you have to include all of the pieces in a proof, or all of the lines. You have to explain everything as if you were explaining it to someone else in this class. So in this part here, see, I don't think that in this class, most students in this class going from line 2 to line 3 would be a jump in logic. Line 3 does not follow, this line here does not follow from this line here, or this sentence here does not follow from this sentence here. There's more that needs to be explained. And what is that? That is that x plus y, let's see, that is that x plus y equals 2n plus 1 plus 2m plus 1, which equals 2n plus 2m plus 2, which is equal to 2n plus m plus 1. Right, and you can see that that has been left out. And it is this, this is why I've decided to make our learning of proofs more about reading proofs in this class, is because to get a sense of what you need to, of how to actually write these things, this is a whole semester in and of itself. And in this class, we want to move past proofwriting and start talking about some really interesting things. Not that proofwriting and logic isn't interesting, but we want to start talking about some really interesting things. And counting and graph theory, induction. Now remember, you will have to do induction proofs. And so understanding these ideas from these worksheets is imperative to you learning to write induction proofs. Okay, it's been fun. As you can tell, I like talking about this stuff, and we'll talk about it a lot more. And I love to meet with students in office hours to talk about their issues they're having with the material. I'm really good with a whiteboard. And there's a whiteboard in Zoom. End proof.